tell you about data rinse. So enterprises often have multiple data scientists working on similar data, and their code is usually checked into a central repository of some kind. Data rinse mines the code in these repositories to extract particular expressions that they use to manipulate the data of particular data sets. And we then present that data so that other scientists working on the same data sets or similar ones can use some of the same code. And we're going to show this as an example using the Kaggle Titanic Survivor Prediction dataset. You can see some code here that loads the dataset. And then if you look at what there is here, it has a bunch of fields. And we are going to, there are a bunch of things you can notice. You probably notice things like nans in the cabin, which would need to be cleaned up. But we are going to focus on fair and age. So fair in particular. Fair is a floating point number that it turns out is useful to bin into categories. And then we'll also show you a quick example with age as well. So now how do you do this? Well, first we've loaded the data set. We get the columns. We then ask our expression extractor to look at those columns for that data set. The result comes here into data, and then we're just going to print out what we got for fair. Now, the way the file works is each result has the set of scripts from which we extracted code, and then for each script we know what function. So for example here, this function fair0 is simply trying to do a fill NA to replace null with the median value, and it's in place equals 2, so it actually mutates it. Most interesting later will be fair1 and fair2. So fair2, if you look at what it's doing, there are 4 pieces of code here, which is essentially binning fair into categories, 4 categories based on the value. So you can see 7.91, 14.45, and so on, other values, the cutoff points. And then if you look at fair1, it's actually doing something rather similar, but it's using pandas.qcut is telling it to break fair into 4 pieces. It then assigns it to fair band, not fair, but it's basically doing the same thing. And there's another script here which is doing a different way to replace nans, and it also has a predicate on for 500. And now notice that some of these do not change the data frame. For example, fair4 clearly does not, and it turns out that fair0 is not going to either. And what we do is we filter functions with the code that says, well, let's take the data set and the function and see if it actually changes the data set. If it does, we keep it. If it doesn't, then it's just it's not as useful for filtering. It's just a predicate displaying something. So what this does is it takes the data frame, makes a copy, runs the function, and then checks if the new one is equal to the old one. And if it isn't, then we keep it. And if it is, if they're equal, that means the function didn't do anything. So then we run this code on our Titanic dataset, and what we've realized for fair is that actually only fair1 and fair2 manipulate the dataset, and those are the ones that we're going to keep, the ones that are splitting fair into bins. And when we do that, we return a list of functions. This list of functions is organized by script, and we actually can show you the Python code that the function does. So let's just look at what fair does. We have fair1, where it's the qcut, and fair2, which is breaking it into these 4 pieces. So these are pieces of code, actual Python definitions that a user could then manipulate and put straight into their code. And the last thing I want to show you is another thing. I said I'd say something about age. It turns out there's one place that computes this age times class. And but before it does that, it actually bins age into categories. And again, our code, because of its static analysis, we know that that happens first, and so we actually extract that dependency for you to use. There's a lot more to look at, more data sets, and it scales well and so on, but that's all in the paper, and that's all I have time to show you now. So with that, thank you very much.